Hello students, welcome to my channel. I am Shumit and today I'll teach you to derive the equation of circle in polar form. Okay, so this is the fourth lecture of this series, and if you haven't still watched my previous videos on polar coordinate system, here I share the link of my playlist in the I button. You can check it out. In this session, we'll first derive the equation of circle in polar form. Then we shall observe some special cases, and also we shall solve some problems. So take your pen and notebook and continue with the discussion. So O is our pole and OX is the initial line. Now there is a circle in this polar system of coordinate. Okay. This is the circle. Its coordinate is point Q. Its center is at point Q, whose coordinate is C, alpha. And its radius is given as A units. So we have to derive the equation of this circle using these polar coordinates. Okay. Now let us take an arbitrary point of the circle. Say P r comma theta is an arbitrary point on this circle. So this point moves along this circle. So if we can find the locus of this point, we will be able to derive the equation of this circle. Now first of all, we will connect the center to the pole, and then we shall connect this arbitrary point P to the pole. Now by the coordinate of center Q, we know that this distance OQ is C units. This distance OQ is C units, and this angle is alpha. Okay. And by the coordinate of point P, we can say that the length of OP is R units, and this entire angle means the angle POX is theta. Okay. So if this angle is theta and this angle is alpha, we can say that this smaller angle means the angle POQ is theta minus alpha. Okay. Now we have already derived the equation, the formula to calculate the distance between 2 points using polar coordinates. If there are 2 points r1 theta 1 and r2 theta 2, say this is point P and this is point Q. Okay. So the distance between these 2 points PQ is given as root over r1 square plus r2 square minus 2r1 r2 cos of theta 2 minus theta 1. Okay. So this is the distance formula, this unit. This is the distance formula between 2 points in polar coordinate plane. So we will use this same formula here also. We know the coordinate of point Q and that of point P. So the distance between point P and Q, we can write PQ is equal to root over. Here this is r1 r2 and this is r1 theta 1 and this is r2 theta 2. So c square plus r square minus 2cr cos of theta minus alpha. Theta minus alpha. This is the distance between point P and Q. And we know that this distance is nothing but the radius of the circle. Since P is a point of the circumference of the circle, so if we connect any point on the circumference to the center, that means this distance is actually the radius of the circle, and this is given as A units. So we can write this, that this is equal to A. Now squaring both sides, we get A square is equal to C square plus R square minus 2CR cos theta minus alpha, and this is the required polar equation of the circle. Okay, this is the polar equation of the circle. Now we should observe some special cases. First, you note it down. Okay. Now we shall move forward to observe some special cases. Special cases. There are three special cases we'll study. So, case 1. Case 1, if alpha is equal to 0. So, if alpha is equal to 0, what happens? Now, one thing you must remember that while studying geometry, you must have to be very much clear about the diagram, because the diagrams only help us to understand the geometry properly. So you should have a good clarity about the diagrams. So here I am drawing a diagram and I tell you to draw it on your own so that you can understand the concept. So say OX is the initial line. Now this is the circle. Okay. Its center is on the initial line. Say this is point Q and its center is on the initial line. Then we can say that if this distance OQ is C, then C comma 0 is the coordinate of this center of the circle. Okay, because this angle alpha becomes 0 here. So the coordinate of the center is C comma alpha. This means when alpha becomes 0, it implies that the initial line passes through the center of the circle. So in this case, initial line passes through the center. Initial line passes through the center of the circle. Okay. So in that case, the equation of the circle will be like this: a square is equal to c square plus r square minus 2cr cos of theta minus alpha, and since alpha is equal to 0, we'll write only theta. Okay. So in that case, this is the equation of the circle: a square is equal to c square plus r square minus 2cr cos theta. Okay. Now case 2. Case 2. What happens if the pole is on the circle? Pole lies on the circumference of the circle. Okay. So case 2 says the pole is on the circle. Now listen carefully, this is a very special case and all these three cases are important. You have to remember this because we use these cases while solving the problems. So pole is on the circle. Now I am drawing the diagram here. If this is a circle, say this is our pole O and OX is the initial line, and here Q is the center of the circle. Okay. So if we connect center to the pole, then this distance is C, and we can say that this distance is nothing but the radius of the circle, which is given as A. So the coordinate, if this angle is alpha, then the coordinate of the center is A comma alpha. Okay. So we can write if the pole is on the circle, then it implies that C is equal to A. So the equation of the circle becomes, in place of C, we'll write A. So it becomes A squared is equal to A squared plus R squared minus 2AR cos of theta minus alpha, which implies that if we cancel out A squares from both sides, we get R is equal to 2A cos of theta minus alpha. This is the equation of the circle in that case. And this equation is very important because we'll use this equation while solving the problems. In most of the cases we'll use this equation, so you should memorize this equation. Okay, so these are two special cases. Now we'll see the third case, and the third case is nothing but the combination of these two cases where the pole is on the circumference of the circle and also the center lies on the initial line. Okay, so case 3. Case 3. If the pole is on the circle, the pole lies on the circle and the center lies on the initial line. Okay, the pole is on the circle and the center lies on the initial line. So let's draw the diagram again. So this is our circle. Now the pole is on the circle. So say this is O, our pole, and this initial line OX passes through the center. So here is our center, say Q. Now obviously this distance is nothing but the radius of the circle. So this distance is A units, and also the angle alpha is 0 here. So the coordinate of center is A comma 0 in that case. In this case we get that C is equal to A and also alpha is equal to 0. So thus the equation of the circle becomes A square is equal to C square. In place of C we will write A because C is equal to A square plus R square minus 2AR cos of theta minus alpha, and alpha is equal to 0, so cos theta. Thus it implies, if we cancel out a squares from both sides, we get r is equal to 2ar, no, r is equal to 2a cos theta. Okay, r cancel out. So this is also an important equation. You should remember this, because now we shall solve some problems and we'll see that these equations are very useful while solving the problems. Actually we will not use the main equation. In most of the cases the problems will be related like this, that we have to use these equations. So these three special cases are very important. You should note it down. I am giving the screen here. Okay students, now we shall solve some problems. This is problem number 1. Write down the polar equation of the circle with radius 2 units with center on the initial line at a distance of 2 units from the pole on the positive side. Now as I told you earlier that in geometry if you can draw the diagram properly, you will understand the concept. Similarly in this problem also, if you can draw its diagram, you will be able to solve the problem very easily. Say this is our circle. Okay, now we are told that its radius is 2 units and the center lies on the initial line. So if this is our initial line OX, say this is the center Q. Okay, now one more thing is told here, that is we are given that the radius is 2 units and also the center is at a distance of 2 units from the pole. If this O is pole, then the distance between the center and the pole is 2 units. We are given that. So we can say that this distance is nothing but the radius of the circle, and this is also given 2 units. So from here we can easily observe that the center also, that the pole also lies on the circumference of the circle. So this is our third special case where the pole lies on the circle and the center is on the initial line. So that's the equation of the circle. In that case we can write r is equal to 2a cos theta, and here a is given 2 units. A is the radius, so this implies r is equal to 4 cos theta, which is the required equation of the circle. Okay, students, next problem. Prove that the equation of the chord joining the points theta is equal to theta 1 and theta is equal to theta 2 on the circle r is equal to 2a cos theta is this. Okay, so we are given the equation of the circle, and there are 2 points with vectorial angle theta 1 and theta 2 on the circle. If we join these 2 points, we will get a chord. So basically we have to find the equation of that chord. Okay, so say this is our equation 1, equation of the circle. Now we have to prove this. Let us assume the equation of the chord is 1 by r is equal to a cos theta plus b sin theta. We can say this because chord is a straight line, and we know this is the general equation of a straight line from my previous lecture. So say this is our equation 2. Okay, now these points theta 1 and theta 2 lie on the circle, so they must satisfy equation 1, right? Because these points lie on the circle. Basically there are 2 points like this. If we join these 2 points, we will get a chord, and we have to find the equation of the chord. We have to show that this equation of the chord is this. Now theta 1 and theta 2 are the vectorial angle of these points, so they lie on the circle, means they will satisfy equation 1. So putting theta 1 and theta 2 respectively in equation 1, we get the end points of the chord are is corresponding to vectorial angle theta 1. We get the radius vector is 2a cos theta 1. So the end point is 2a cos theta 1 comma theta 1, and corresponding to vectorial angle theta 2, we get the end point is 2a cos theta 2 comma theta 2. Okay, these are 2 end points of the chord. Now since these are the end points of the chord, they lie on the chord, so they will satisfy equation 2, and we'll put these values in equation 2. They will get, if we put this here, we get 1 by r is equal to, in place of theta we will write theta 1, in place of r we will write 2a cos theta. So we get 1 by 2a cos theta 1 is equal to a cos theta 1 minus plus b sin theta 1. Okay, now this implies a into 2a, if we multiply both sides by 2a cos theta 1, we get 2a cos square theta 1 plus b into 2a sin theta 1, 2a sin theta 1 into cos theta 1. Now 2 sin theta 1 into cos theta 1 means sin 2 theta 1. The formula of sin 2 theta is 2 sin theta cos theta. So 2 sin theta 1 into 2 cos sin theta 1 into cos theta 1 is is equal to sin 2 theta 1. So you can write 2a sin 2 theta 1. Okay. And if we take this one this side, then this becomes minus 1 is equal to 0. This is one equation. So this is our equation number 3. And also if we put this point here in equation 2, we get a into 2a cos square theta 2 plus b into 2a sin 2 theta 2 minus 1. This is equal to 0. So this is our equation 4. Okay. Now we have to solve these two equations by cross multiplication method. Then we will get a and b, and we will put these values of a and b here in equation 2. Then we will get the required equation of the chord. So first we note it down. Okay students, now we shall solve these two equations by cross multiplication method. Okay, I have written this wrong, sorry. This is only a sin 2 sin theta 1 cos theta 1 becomes sin 2 theta 1. So here we should not write 2. This is a sin 2 theta 1 and this is a sin 2 theta 2. Okay. Now we will solve these two equations by cross multiplication method. So we can write okay. So a by this minus this, so a sin 2 theta 2 minus a sin 2 theta 1 is equal to b by this minus this, so 2a cos square theta 1 2a cos square theta 1 minus 2a cos square theta 2. Okay, this is equal to 1 by this into this minus this into this. So this becomes 2a square cos square theta 1 2a square cos square theta 1 2a square cos square theta 1 into sin 2 theta 2 sin 2 theta 2 minus this into this. So 2a square cos square theta 2 into sin 2 theta 1 2a square cos square theta 2 into sin 2 theta 1. Okay, 2a square cos square theta 2 into sin 2 theta 1. This is from here we will get a and we will get b. Let us solve further. This implies a is equal to this quantity, this numerator divided by this quantity. Okay, so a is equal to, now we take a common from the numerator, so a into sin 2 theta 2 minus sin 2 theta 1. Okay, this divided by this quantity, this is the denominator, and we will take 2a square common from the denominator. So 2a square into cos square theta 1, 2a square into cos square theta 1 into, now sin 2 theta 2 means 2 sin theta 2 into cos theta 2, we can write this, so we will split this, 2 sin theta 2 into cos theta 2 minus 2a square is common and cos square theta 2 into sin 2 theta 1 means 2 sin theta 1 into cos theta 1. So 2 sin theta 1 into cos theta 1. Okay, this is the denominator. Now we'll use the trigonometric formula here. So we get A is equal to sin C minus sin D. You know the formula, sin C minus sin D is equal to 2 cos C plus D by 2 into sin C minus D by 2. We'll use this here. So we get 2A cos of theta 2 plus theta 1 into sin of theta 2 minus theta 1. Okay, divided by the denominator is, now take cos theta 1 cos theta 2 common from these two quantities. Okay, here is cos theta 1 cos theta 2 and cos theta 1 cos theta 2. So we will take this common outside. Then the denominator becomes 2a squared cos theta 1 into cos theta 2 into, now if you take cos theta 1 cos theta 2 common, what are we left with? We'll see this. Okay, cos theta 1 and cos theta 2 common. Cos theta 1 cos theta 2 gets common. Then we are left with actually sin theta 2 cos theta 1 minus cos theta 2 sin theta 1. Okay, yes, sin theta 2 cos theta 1 minus cos theta 2 sin theta 1. We are left with this. Okay, and this is the formula of this. Sin A cos B minus cos A sin B means sin A minus B. So we can write sin theta 2 minus theta 1 here. Then we cut out sin theta 1, theta 2 minus theta 1 from numerator and denominator, and we are left with our required value of A, and that is equal to 2A cos theta 2 plus theta 1, 2A cos theta 2 plus theta 1 divided by 2A squared cos theta 1 into cos theta 2. 2A squared, and also if we cut 2 and A, then we get A cos theta 1 into cos theta 2. Okay, no, sorry, I think there was one more 2 here. Okay, so this is 4 and this is also 4 and this becomes 2. So we get 2A cos theta 1 into cos theta 2. So A is equal to A cos theta 2 plus theta 1 divided by 2A cos theta 1 into cos theta 2. Similarly, if we solve in the similar way, we will get that D is equal to A sin theta 1 plus theta 2 divided by 2A cos theta 1 into cos theta 2. Okay, now we'll put these values of A and B in our equation 2, that is the equation of the chord, and we'll get the required condition. Okay, so put these values in equation 2, then we'll get our required equation of the chord, that is this. So the equation of the chord is 1 by r is equal to a cos theta plus b sin theta. Instead of a, we will write this a cos theta 1 plus theta 2 divided by 2a cos theta 1 into cos theta 2 into cos theta. This is a cos theta plus b sin theta. In place of b, we will write a sin theta 1 plus theta 2 divided by 2a cos theta 1 into cos theta 2. Okay, this into sin theta, a cos theta plus b sin theta. This is the equation of the chord. Now if you simplify this, you will get this. It's very easy, just multiply both sides by 2a cos theta 1 cos theta. Okay, I am doing this. Then we take r that side and we get 2a, okay, 2a cos theta 1 into cos theta 2 divided by r is equal to, this is our a. From both the terms we can take a common, then we get a into cos theta 1 plus theta 2 plus sin theta 1 plus theta 2. Okay, cos theta 1 plus theta 2 into cos theta plus sin theta 1 plus theta 2 into sin theta. Okay, now this is cos a cos b plus sin a sin b, which is the formula of cos a minus b. Cos a minus b is equal to cos a cos b plus sin a sin b. So we can write this. This implies that we'll get the finally, we'll get this result. If we take r that side, then we get 2, we get r, that is cos a minus b. So cos theta minus theta 1 minus theta 2, okay, is equal to 2a cos theta 1 into cos theta 2, 2a cos theta 1 into cos theta 2. R cos theta minus theta 1 minus theta 2 is equal to 2a cos theta 1 into cos theta 2. This is the required equation of the chord, and here we are told to prove this. Okay, so hence proved. Hence proved. Note it down. Okay students, now I shall not include more problems here because the video is going very lengthy. So, but I will bring a separate video on problem solving at the end of this series. So this is all for today's session. I hope you have understood the concept and the problems also. So if you have any doubts regarding the discussion, let me know in the comment section. Also for the PDF notes of this session, check out the description box below. And thank you for watching. Keep studying and keep growing.